Hello, welcome back to my channel, White Mechanical Engineers. This time we are talking about the silo. It's a 40-ton cement silo, and I did this project around 4 years ago. Yeah, and you see on the screens there is a logo here, ES Engineering. Actually, the ES meaning is engineering sharing knowledge. Yeah, uh, and sharing solutions in case we have same problem, and then we share that, so it make this the solutions faster, and then to not to reinvent the wheel if the case may be already solved by other engineers. So straight to the challenge. As you can see on the screens, the project quite challenging. This project background was an upgrade and adding more capacity to the plant. Uh, at the time, the company did a good business, so a company appointed me to increase the plant capacity. One of the uh, one of the scope of the project, yeah, to increase the capacity is to add the silo, but this quite challenging, as you can see on the top screen. Yeah, quite challenging because I have limited space and I have no access into the heavy equipment to lift the silo. Here's our neighbors, very crowded building. Here is the existing plant line, production line. Yeah, and this a column. Yeah, columns of steel structure of the building, and this is the existing silo. Yeah, there already, and I have to add the silo here. So the distance between them, center to center, is only 4.7 meters. So quite challenging, but okay, we can solve the problem. Yeah. So uh, before we solve the problem, we make assessment of the project risk. Yeah, the ground or the soil is quite soft at the time. Yeah, um, so I have to hire really proven civil work uh, expert, especially in the foundation, and they calculate the deadlock and then etc., the wind load and etc., and they ask and they advise us at what type of foundation I have to put into that place, so quite strong enough. Sorry. At the time, I requested the safety factor a bit high, 4 to 5. So before that, we do of course the uh, soil test, and from that point they have a calculation for the bearing load, yeah, of that uh, soil and etc., and then they will determine how much the depth of the foundation. So at the time they decide us, due to the construction we cannot do and piling, so they they, they ask us to make a bore pile by using manual digging until 18 meters, yeah, to the ground. So this is quite challenging because people have to go to the grounds and they do manual reading, and then have to counter the risk, the hazard there, oxygen, etc. So we give them a masker with oxygens, and we're afraid that suddenly something bad happened there when digging it. And the second is a steel structure. Yeah, steel structures. Actually, I'm not a civil engineer, but due to the limitation of the budget, I have to do stress analysis for this steel structure anyway. Yeah, so I have to measure how much the safety factor they have to put it in, and then to choose the what kind of steel structure profile and dimension I have to do. So I'm so lucky that no, not me, all of us so lucky that this kind of job now can be done is very fast using in this case I using SolidWorks static analysis without the presence of buckling analysis. So I can sure that everything's okay. Yeah. And then the third is quite challenging. Load cell. Load cells. We put load cell into the silos to make a reliable reading and fast readings and closing and opening of the consumption of the cement. But the problem is how this load cell. Yeah, because you know you have to do some on-field calibration and etc. So what is the strategy actually for this for this load cell? So you have to come to that strategy in case you buy the load cell and suddenly the display is not, it's a different brand, and then you do nothing with the display and then the load cell, and suddenly you mess up the project. I will discuss this later on. Yeah, how the strategy for this case in case you want also to have a load cell into your system. And the fourth is the erection and installation. All right, straight. What to do? Yeah, foundations and etc. You tackle all the problems. Yeah, and then predict what problem you will have. That's a good things in engineering. You have to foresee the problems and then what you want to do to this problem, and then it happen, what's your mitigation action to this the problem. So it's kind of you have to dig in the failure mode and effect analysis into the project. It's basically a project that quite challenging in the situation of execution. Yeah, in this case narrow space and etc. Alright, so I did appendix, so we discussed this appendix. Sorry. So this the bore pile. That guy is digging in after he dig around. This is diameter around 80 cm and dig in around into the ground around 15 meters, and this and then totally 6 of it. And this guy now is doing a steel reinforced bar, yeah, rebars installations for the pile caps. Alright, so this is the silo actually. This is the silo. I drew it, I designed by myself using SolidWorks. I studied SolidWorks a long time ago, so easy for me to perform this project. Yeah, this is the screw conveyors. Yeah, the screw conveyor. And then for you that using screw conveyor, I recommend you use a ball joint like this. It's like a universal joint rather than a fixed flank joint, because if you're using ball joints on the field, it's easy for you to tilt the screw conveyors and to meet your certain of degree adjustment. Yeah, if using a fixed one, it's quite challenging. This WAM made in Italy, WAM screw conveyors. The cost is additional cost is not so expensive. Yeah, to have these ball joints. It's like a universal joints, and after this fix, you can do welding in the joint to make it fixed rather than fixed flanks. Quite challenging fixed flanks. Then this is the situation of design of the support of the steel structure. Also I did this, yeah, and then I did simulation, yeah, simulation of the load using a finite element analysis. Yeah, now the finite element analysis is very good compared to when I was in the university times. University time is very tough. Yeah, takes many hours to solve the problem even using computer. Now it's very fast. So I mesh, yeah, see, I mesh the steel structure. Everything is in one joint. This mesh using Jacobian, yeah, and then you see total nodes 350k, yeah, nodes, yeah. I think it's quite enough already. Imagine you have a 350,000 small dots into your simulation. So I believe this number of nodes already represent the perfect situation to know the stress of analysis, the stress result, and etc. By apply the loading of the material, loading of the material inside, and then the loading of the weight itself, and etc. and etc. So this is the result: stress distributions of the steel structure that support the silo. This is the silo, yeah, and then this is the colors, yeah, of the stress result. As you can see, this is the failure mode using von Mises, very famous in mechanical engineering, using von Mises and Tresca and etc. And this is the result. Looks like, as you can see here, looks like very high, very high the safety factor compared to the result of this simulation. So also you can zoom in using SolidWorks, yeah, the critical area that high of stress, yeah. It makes sense that high of stress is here because this place is directly support the weight of this load silo. So you can see here, yeah. And then also this is using a von Mises one, yeah. Then also von Mises they can directly calculate the safety factors of your steel structure, yeah. It's a comparison of this stress analysis result, and then you divide with the steel yield strength, and you get a safety factor. This is a very what do you call it, very simple one. There are also von Mises formula for fatigue and continuous load and etc. So you see here safety factor is very high, yeah, 69, and the lowest safety factor is 3.9 in this area, yeah, the lowest safety factor in this area. I think 3.9 is very good safety factor actually, yeah. Usually mechanical engineer, they will design safety factor is a 2, yeah. Civil engineer for foundation usually, let's say 3 to 5, yeah. But this the minimum is 3.9, but let's, yeah, I'm a mechanical engineer, so I'm afraid miscalculation, so I put 3.9 is okay. So you zoom the critical safety factor is here, yeah. It's very close to the load of the weight and etc. Why it's a very high safety factor, okay. And then displacement is very important to know, yeah. So how much actually displacement of the this steel structure, yeah, after put it in using load, yeah, what is the displacement, the maximum displacement? So as you can see here, the maximum displacement is 1.3 mm, yeah, 1.3 mm. I think it's okay, and then it's already proven by von Mises formula in this stress analysis. The safety factor is a minimum, minimum 3.9 or close to 4. The maximum is very high, around 16, etc. And then you can magnitude the location of displacement, yeah. is at the bracing here, yeah, quite high, but still allowable, yeah, 1.3 the maximum. And then also elongation of the silo structure is in the very safe, yeah. You are from mechanical engineering, I think very understand what the meaning of elongation and etc. So we don't need to talk about it. Okay, also magnify elongations, very small elongation, yeah. So you cannot see by the eyes. And on-site erection method, this is very interesting. After the foundation done, yeah, I have to raise these three pillar or three support structure, and I put remaining one is open, so I need that open because I need to make silo here, yeah, to weld the silo cell. And then at the top I have kind of from chain what do you call it? Chains, spokes, kind of like that, chain, lifting chain, yeah. So after one cell welded very well, yeah, next to the next cell, yeah, so I need this thing to lift that joint already welded very well. So at the last point is of course to weld the cone, yeah, the bottom side. So that's the method. So we put it things there, we make a three legs there, and then we measure the diagonal, it should be good, and etc. And then we remain one of the column open to put the cell there, and then finally after everything done, we will close this with additional final column. This is me, yeah. It's very, as you can see here, yeah, this is the cell now already lifted to the top. So this is waiting for the cone, yeah. After lifting it, we will install the cone, yeah, here, and then weld it here, yeah. Unfortunately I didn't use helmet at that time, yeah. So I missed the safety, I think, but I will not repeat that again, yeah. Okay, this is the foundation, yeah. This is the foundation. So that's the methods. After that, we will close by adding the last column here, yeah, after the cone join. We believe, I believe three support is still enough considering the safety factor, that with the full load and the material there is very high, so I think that's not problem. So it proved already not problem actually. So this is another view, yeah, when the cell already join everything there. This is the existing silo that I already mentioned before. So now we are waiting to put the cone, yeah, here, yeah, by lifting this using that chains lifting mechanism. So another view, yeah, after everything, the cone here is already connected, yeah. Now we are closing it with the last column. This is the view after the last column is fitted, and this is the joints that we did stress analysis as well. This is the top view, looks like the joints, yeah. And then the load cell will be around here, yeah, the load cell will be around here. So we will lift the silo to put the load cell there, yeah, later on. It after this 2 years, I think. After 2 years, after I put the load cell, yeah, the load cell here, the load cell is quite expensive brand from UK, Visai, I think, yeah, the brand is Visai. And then the load cells now is already corroded. This load cell is actually stainless steel, but very close proximity to the sea, yeah, and the wind bring the salt and etc. As you can see, really rusty. Yep, quite terrible, I think. Really, really rusty. All right. So this again the ball joint, yeah, and paint it here, yeah. Okay. We discussed about the lot cell. The lot cells I order from UK with the specific constraint that I don't want to miss during calibration. So I asked the lot cell providers, you provide me the lot cell including the display, but you have to do lab calibrations lot cell and the display. So they have to put the lot cell and the display I order to them, connect it to the lot cell, yeah, and lab calibration they press usually using the press machine, yeah, let's say 1 ton, 3 ton, 4 ton, and etc. And my lot cell here is each lot cell capable to sustain 30 tons operating condition, yeah, 30 tons, so 100 multiplied by 4 is 120 tons. I have 40 tons something, so I also have around 3 safety factor here, there, yeah. So when the lot cell come in and arrive in, I don't need to do any calibration anymore. I only need to check each lot cell. I have a 4 lot cell there. I only want to check how much millivolt generated in that 4 lot cell. Yeah, so it means I have to do cornering. Yeah, let's say one lot cells only 1.5 millivolt, another lot cell maybe not so 1.5, but let's say 1.4. So I need to do cornering. But if 3 lot cells good and 1 lot cell is bad reading, that's not good. So it means not all 4 lot cell or not all 4 loads actually distributed to the 4 lot cell. But at the time it's quite good. So the trimming at the lot cell junction box is not so difficult, yeah. So we do trimming because in the junction box there is actually a thermistor there to adjust it and then transfer. So the lot cell directly read the wake of the silo, the wake of the screw conveyor here. So if that already good, and then also calibrated on their laboratory, yeah, I just only need to press tear, zeroing, and then I put the material inside. So that's already correct. So in case you also facing or the same problem and you want to apply this, so be careful. You have to order the lot cell to the same company, order the indicator to the same company, and they ask them to do calibration of the lot cell together with your lot cell indicators. So when the product arrive, you just need to tear, press the button. That's all. If you don't do that, quite challenging, yeah. After you install everything and then your lot cell indicator doesn't know, how to translate that millivolt analog voltage into the digital one. But in other case, I have the same problem like this, also quite challenging. That will be another session. That I upgrade the silo, yeah, I upgrade the silo and to cut some things, and I have to cut cost because if I send that to UK, quite expensive. So I did by myself. We call it electronic calibrator. We will talk about that later on in other session. So that's all, I think, this presentation. So if you have the same problems, yeah, the same situations, I hope this video can give you the big picture and then to solve the problem that you are now facing. So if you like it, you can share, and then if you want the material, you can just request by put the comment below. Thank you very much. Enjoy your time and love sharing the knowledge. Bye bye.